Hello, hello. Today I have the puzzle Unzipped by Marty Sears and Patrick Gass, aka Viking Prime. And it looks really fun. Well, I'll just go into the rules. So we have normal Sudoku rules apply, which means that every row, every column, and every marked 3x3 box contains the digits 1 to 9 exactly once each. We have Kropki rules. So along this Kropki dot, the digits will be in 2 to 1 ratio, meaning it's either 1 and 2, 2 and 4, 3 and 6, 4 and 8 in some order. Along the white Kropki dot, they have a difference of 1. So these two digits will be consecutive in some order. We have palindrome lines. That's these black-gray lines. Palindrome lines read the same forwards and backwards. So on this palindrome line, these two will be the same. On this palindrome line, right, these two digits will be the same. These two digits will be the same. It reads the same forwards and backwards. We've got same difference lines. So on this line, there'll be some difference between two adjacent digits, and that difference will be the same across every adjacent digit on the same line, although between lines they might have difference. So if this were a same difference line, it would have to have a difference of 1, because I couldn't possibly have 2. We'll hopefully get into that in the solve, I bet. So these will all have a difference of 1, but that doesn't mean this line would have to have a difference of 1 as well. These might have a difference of 3, and then these might also have a difference of 3. So the difference on this line can be different from the difference on this line. And then our lavender lines or zipper lines, I guess this puzzle came about before the innovation of putting circles in the center of lines. But what a zipper line does is it sums. So it's like a palindrome line. The ends of a line are going to be the same as you move towards the center. The digits are the same, equal distance from the line. We're going to have the same kind of reference cells here on a zipper line, except now instead of being the same digit, we're going to add them together, and that's going to have the same sum for all pairs. And in the center, which is going to, in all these cases, are just a single line or single cell, that will just be the sum. So for example, this might be 3 and 4, summing to 7, which I have here. I might have, say, 2 and 5 here. And this might also be 5 and 2, right? So that would be a perfectly valid way to fill out this zipper line. And then the fun part, I think, of this puzzle is the modifier, Shenanigans, which says each line is one of the above constraint line types. So we're just talking about lines. I don't think Shenanigans applies to the Kropkis. It would be quite funny, though, if this were a black Kropki dot and this were a white Kropki dot or something. But I don't think that applies here. So each of the lines of these 3 line types, one is for each line is one of the above constraint line types, but some of these are lying. So this might not actually be a zipper line, for example. This might be a, say, same difference line or a palindrome line. Like, this can't be a palindrome line, but it could be a same difference line, say. But if it's lying, it can't also satisfy the other line. So for example, I couldn't have a line that was both, like this line could in theory be both a zipper and a palindrome. But if this were lying, it couldn't be also a zipper. It could be a zipper, but it can also be a palindrome line if it's lying. It says wrong colored lines are exactly those lines which have the digit D on them, and D is to be determined by the solver. So, right, because if it's not lying, it could be both a palindrome line and something else. But if it has this digit D on it, so let's say the digit D is 1. I don't know what it is, but let's say it's 1. Then this would not be allowed because it is a valid palindrome line, and 1 is the special digit that signifies the lying lines. Yeah, so let's just try it out. Whoops. And see how we do. So a couple things that I noticed as I was explaining the rules is that this line has to lie, because it can't be a palindrome because those two cells cannot possibly have the same digit in them because they're in the same box. So this one is definitely lying. But I think that is the only line I noticed that is self-evidently lying. There are lines which, if they are lying, like all of these lines that are more or less contained to a box, if they're lying, they're going to kind of the other colorful types. They're not becoming palindromes, because this purple line can't be a palindrome, this can't be a palindrome, this can't be a palindrome, this can't be a palindrome, right? So Yes. And these cells are probably, these lines are probably lying. So what we're probably going to end up with is a zipper over here and a same difference over here. I say they're probably lying because there are only two cells where our special digit D could be that would prevent us from lying. Oh, and in fact, in fact, one of them has to be lying. Because so if this is not lying, what that would mean is my special digit is here. Which means that special digit can't be over here, which means it's definitely on the purple line. So at least, it could be that they're both lying, but at least one of them is lying. And now, is there something where they can't both be of the same type, so they both have to be lying? That would be useful. Let's see, what would happen if they were both... What would happen if they were both same difference line? So if it's the same difference line, it has to have a difference of 1. Because on a same difference line, normally you'd be able to go kind of up and down across the line. I was about to say you can do that here, but I don't think that actually works. So in a same difference line, if this were spread out across boxes, it could be something like 1, 3, 5, 3, right, 5. I just want to make sure. Okay, yeah, 5, 7, 9, which obviously doesn't work because I'm repeating digits in a box. So I can't kind of turn around. So once I start going, if I try going up by 2 every time, I run out of digits. So it has to have a difference of 1. And I don't know where it would start. So, but if this were a real same difference line, it would basically be a thermometer with white Kropki dots all across. And I don't know where it would start. It could start here, it could start here. I don't know what digit it would start on. But it'd be something like that. And I wonder if there's a reason I couldn't just have it go the other way. That seems like it could be fine. Hold on. So if this is a real same difference line, these digits are 1, 2, 8, or 9, because those are the digits that could possibly be missing from this line. So this line either goes from 1 to 7, in which case the digits are 8, 9. It could be 2 to 8, in which case those are 1, 9, or it can be 3 to 7, in which case this is 8, 9. No, it's 1, 2, I mean. So if these were both same difference lines, one of them would be 3 to 7 with an 8, 9 here, and one of them would be 1 to 7. I think I did that. One of them would be 1 to 7 with an 8, 9. One of them would be 3 to 9 with a 1, 2. But I think that's okay. I don't see why that wouldn't be okay. 4, 5, 6, 7, 3, 4. Oh no, it just doesn't work. Wow. Yeah, it actually doesn't work because again, it's all symmetric, so it doesn't really matter which way. Suppose this is the 1 to 7 line. Now, where do I put the 3 to 9 line here? Well, I can't put 3 here because of that. So I have to do 3, 4, 5, but then I put a 5 across from this. So I can't have two same difference lines. Can I have two zipper lines? If they're both zipper lines, no, I can't have two zipper lines. That's easier to see because I can't have two zipper lines because on a zipper line, I can't put 9 on the ends of a zipper. So there has to be a 9 here. Where, I mean, I don't care what this big sum is. It could be 9, but it might not be 9. But if it's not 9, the 9 can't go on one of the things we're adding. So 9 would go in here. But I also have to have 9 over here in this zipper line. So that just doesn't work. So these are both lying. So this is a same difference line. Which I can put a 4, 5, 6 is kind of the best I can do here. And this is a zipper line, which has 7, 8, 9 in it. And these digits are therefore not the special lying digit, which doesn't mean these palindrome lines are true, but it means they're at least true up to what we know from those. And these are 1, 2, 8, or 9, as we said before, because this is the same difference line. I don't know where this, and this is going to continue. So this effectively, Let me turn on my pen tool. This effectively extends my same difference line by 1. So this actually has to be 1 or 9. That's still 1, 2, 8, or 9. This is also 1, 2, 8, or 9. Because I have a Kropki, this is a difference of 1. This is also a difference of 1, right? This is effectively a thermometer with Kropkis, with white Kropki dots all over it. I just don't know where the ball bend is. And since I have 8 digits here, I'm either going 1 to 8 or I'm going 2 to 9. The other extra digit is here. And as you said before, on the zipper line, we have to have a 9. There we go. We have to have a 9 here, so that's a 1. So this can't be an 8 anymore. So this is either going 9 to 2 or 2 to 9, but either way, this is probably the same digit, right? 2, 3, 4, 5, 6, 9, 8, 7, 2, 3, 4. Oh, no. It's off by, it's an even, they're an even number, so I don't have a strict center. Yeah, something like this. So I don't know which way it goes, but it's going around one way or the other. Oh, this isn't 9, same exact, that's not a 9. Okay, so we get 2, 3, 4, 5, 6, 7, 8, 9. Lovely. And then, how does that help? I'm going to erase this just so I don't, whoops. I'm going to erase this just because it's not, I've got the digits filled in, so it's not helping anymore. Well, this can't be 9 because it can't be on a Kropki dot. Okay, what are possibilities here? This could be a 7, in which case that's 8, 9, and we have an 8 here. This could be an 8, in which case it's 4, 9, I'll put a 4 here. This could be a 9, in which case these sum to 9, because if this is a 9, sorry, I'll actually explain all those. If this is a 7, I can't put 8 or 9 on these, so they have to go in here. And 9 can't go in the Kropki, so the 9 would go here. If this is an 8, I can't put 9 on these lines. I also can't put 4, because 4 would have to pair with another 4 to sum to 8. So this would be 8, 4, sorry, 9, 4. And 9 can't go on the Kropki again, so it's to go here. If this is a 9, each of these sum to 9, those sum to 9, those sum to 9. I can add all that up. That's 36. The remaining sum here is also 9. Or, I just happen to know that the digits 1 to 9 are the digit 9, and then 4 ways of pairing up to 9. 1, 8, 2, 7, 3, 6, 4, 5. 3 of those pairs would be on these lines, and 1, the missing one, would have to go here. Oh, and because this would have to be 4 or 5. So this is either 5 or 9, and this is either 4 or 8. Those are my possible choices. If this is an 8, that's a 4. If this is a 4, that's a 2, because 8 is taken over here. Right, basically, to get those, I just went through every single possibility. Right, 7 was 8, 9. 8 was 4, 9. 9 was 4, 5. 5 can't go on the Kropki because I can't put 2.5 or 10 in the other cell. So if this is 2, 4, oh, so now this can't be 7, because if this is 2, 4, this has to be 3 or 5, which are both taken over here. So that can't be 7. I don't think that gets rid of a possibility. Oh, it gets rid of 8. It gets rid of 8, I think, because if this is an 8, we get 4, 9. And if it's 9, we get 4, 5. So this is 4 either way. So this is now either 6 or 7, depending on which this is. Can I do 3 has to go on this line somewhere. So 3 is over here, and 3 can't go across from 5 because of this, so this can't be 8. So that's a 9, that's a 5. 6 is somewhere up here. The other pair is 1, 8, and I know the 1 goes down here, so that's a 1, 3 pair. This is a 6, 8 pair, that's a 7. And now 1, 2, and 4, and 5 are not our special digits. So our special digit is either 3 or 6 plus. And I can fill in these digits. These are 1, 2, 9. These are 3, 7, 8. And these are 4, 5, 6. I wanted to try the same trick I did over here, but it doesn't work because I can put 9s in these cells. Yeah, it's just not as nice. But one thing worth noting is that, again, if these lines are lying, they can't be palindrome lines because the end digits, I mean, all these digits, all these possible palindrome pairs see each other. So can this be a real zipper line or a real same difference line? The difference I think has to be 1 because so normally you might think, well, you could turn around at some point, right? So this could be, well, because we're leaving the box. So here we couldn't, by turn around, I mean have the difference, have the next digit go higher and then back lower. But if that happens, the second digit, if it turns around, the next digit has to be the same as, so like if we turn around here, these two be the same, which is obviously silly. Here, oh, here we could turn around. Oh, no, it doesn't work. So I could do 3, 5, 7, 5. Oh, but it doesn't work because then those will be the same. Okay. So I can't, it's not as easy as I thought, but you can't turn around because if you do, those digits will be the same. Or those digits will be the same. Right? The only possible place to turn around would be here, where this is, or I guess here rather, when you're coming into the box. But if you do that, you end up making those the same. So you can't turn around, and this is a long line, so this has to be a difference of 1. So this actually is quite restricted on the ends. So if this is the low end, it has to be 3, 4, 5, 6, 7, 8, 9. And if this is the low end, this is 3. Either of those work. Well, what would the digit? So if this is real, that means our special digit is not on it. And our special digit, what would the special digit in these cases? If this is 3 to 9, no, if this is 3 to 9, my special digit is 1 or 2, which it's not because this line is lying and it doesn't contain 1 or 2. So that actually, that way is out. So if it's a real same difference line, it's like this, and the special digit is 1 or 9. It's not 1, so it'd have to be 9. 9 would have to be our special digit. But that seems fine. How about up here? I'm just trying to remember. I'll have to remember. If this is real, it's 2 to 8 this way, and 9 is our special digit. What goes up here? And this just could easily be a zipper line, I think. Except for the fact that I have to avoid having a special digit on it. What happens if it's the same difference line? It's exactly symmetric to this, right? So, oh, so so these can't both be same difference lines. So they're either both lying or both telling the truth. No. They could both be zippers. They could both be zippers. Wait, no, because if this is lying, it goes the other way, right? So I could have, what is 2, 3, 4, 5, 6, 7, 8, and this one's telling the truth because it doesn't have a 9. But this one now could be 3, 4, 5, 6, 7, 8, 9. It's lying because it does have a 9. So it's not symmetric. I don't know. That's too. I don't think that's the play. So what am I supposed to look at now? How about this palindrome line, or this palindrome? Well, actually, they're both interesting because they essentially, if it's real, it puts a digit here. Well, this can't. Okay, this one. Neither of them can be same difference lines, because if they were same difference line, this would have to be 3 or 5 in this case. It would have to be 3 or 1 in this case, which is not a possibility. So these are not same difference lines. So they're either real palindrome lines or lying zipper lines. If this one is a lying zipper line, that has to be a 9. In which case those are still 4, 5. So if it's a palindrome line, these are 4, 5 in this order. If it's a lying zipper line, that's a 9, and it's 4 or 5 in this order. But either way, I get a 4 or 5 pair here, which puts a 6 there. That is really special. I can do the same thing here now, because it's not a same difference line. If it's a palindrome line, it's 1, 2 here. If it's a zipper line, it has to have a liar in it. But the liar, the only thing, I mean, this would have to be the sum because it's a zipper line. The only digit, so if it's a palindrome line, it's 2, 1. If it's a zipper line, the sum is here, and the only digit that could possibly be our special digit that's less than 5 is a 3, because none of these are a special digit. So I'd have to have a 3 on here. So either the 3 would pair with the 2 for 5, making this a 4. So it's either 3, 4, or this is a 4 and it's 3, 2. But it can't be 3, 4. Hold on, it can't be 3, 4 because we have a 4 up here. So it would have to be 3, 2. And so this is a 2 either way. It's not quite as good. I don't get a 9 here. Oh, but that does fix this. Now that fixes this line because this has to be a zipper now. Because we said the only way this worked as a true same difference line is 2, 3, 4, 5, 6, 7, 8. Which means it's a zipper line. I was going to say it could be 5, but it can't. So it's at least, yeah, it is at least 7, 8, or 9. But it's not as just as simple as that there are 3 sums on it. Originally I thought there are 3 sums, so I need 3 different ways to sum to that digit. So it's got to be at least 7, but that's not true. Oh, in fact, this can't be 7 either. Hold on. Does this have to be 9? So the way I'm thinking about it now, so ignore the bad way. The way I think about this now is I need 2 different ways to sum to whatever this digit is. This pair and this pair. And 2 of those ways are taken by these. Like if this is 7, this is either 1, 2, in which case the only way left is 3, 4. So that breaks. Or it's 3, 2, in which case 1, 6, still breaks. If it's 8, and that's 1, 2, we have 3, 5 left, but not another one. If it's 3, 2, we have 1, 7 left, but not another one. So these are all, so this is a 9, and that's a 1. And 7 is one of these because it's going to pair with the 2. Excuse me, sorry. The other one's going to be a pair with the 1 or the 3. So it'll either be 6 or 8. So these are from 6, 7, 8. And definitely a 7. And the other digits are in here somehow. Oh, and one of these is going to be a 4 or 5 pair. Oh, but this will get disambiguated by... What if it's a palindrome? It must be this one. So let's think about this line for a second. What can this be? Because it's not a palindrome. So it's got to be lying. And if it's lying, okay, suppose it's a zipper line. That's automatically a 2. That then becomes a 5 to make this 7. Because it can't be 4 or 6 because there's no possibility for 6 here. Because I can't put 9 in a zipper line. So if this is a zipper line, it's a 7 in the middle. So what do I put in the ends? It can't be 2, 5 because there's 2's in both places. It could be 3, 4 this way. It could be 1, 6 either way. Yeah, okay, so can it be a same difference line? I mean, this makes it real hard. 9 means you have to go these would be the same digit. And it couldn't be 3, because if it's 9, 3, that's a difference of 6. We have to go back up to 9, which doesn't work. So if it's 9, you have to go 8 or 7. 8 would go to 7, which doesn't work. So it'd be 9, 7, 5, 3, 7. That works. If it's 2, this has to be 3, because if I go up to 7, I have to go back down to 2, which won't work. So if it's 2, it's 1, 2, 3, 4, 3, or 5. I almost said therefore this has to be 3 or 5, but this could still be a zipper line with a 7 here. Was there no 8 either way? Well, if this is 8, it's not a zipper line, so it's the same difference. That's 9, 8. So yeah, so there's no 8 here, at least. But that is small potatoes. 1, 3, 7. This is 1, 3, or 7. Okay. Okay, so this is a... Yeah, this can't be a true zipper line anymore, because if it were a real zipper, it certainly can be 1 or 3. If it's 7, we have the same issue where this 2 of my 7 sums are taken. 3, 4 is gone, 2, 5 is gone. So these are both 1, 6. This will be a 1, 6 pair, and this will be a 1, 6 pair, which doesn't work. So this is a same difference line. It has a difference of 1. Oh, but no, that's... I broke it. Hold on. Did I do something wrong there? 1 is gone. 1 is gone. So that's a 3. That's a 7. That's an... Oops. That's an 8. Oh, so this is lying. And that is 4. And 3 is our liar digit. Okay. 3 is our liar digit. So, and now this is a real zipper because it can't be a same difference line, because 8, I'd have to put 9, 7 here, 8, 9 or 7 here. It just doesn't work. So this is a zipper line, and these are from 5, 3 is gone because it's a 5. So these are from 1, 2, 6, 7. This is a 3, 9 pair. And 3 is our liar digit. So this could break something. I feel like I should have more somehow. Okay, those aren't 7. What is this? So 7. Okay, it's either, so if it's a zipper line, it's 2, 5, and then whatever. If it's a palindrome line, it's 9, 7, 5. So this is 5 either. Oh, I have a 4 right here. Okay, well that was a 5 either way from this line. 5 therefore goes here. 4 goes here. Unsurprisingly, by Sudoku. And this is a zipper sum line. What is this sum? It's not 2, 7. 3, 6 is possible. Oh, it has to have a 3 on it, and it's not here. So this is a 3, 6 sum one way. So the 3 goes here, the 6 goes here. And now, oh, this is 2 possibilities still. For some reason I had 3, 6 in my head. But if this is a zipper, it's a 7. So this is a 4 if it's a zipper line, and that's a 2. And if it's the same difference line, that's 7, 9, 7. And this is a real, oh, it can be 4 because of this 8. So that's a 7. This is a same difference line. That's a 1. That's my 2, 6. That's my 1, 7. Now what? Now, can I do this one yet? This one doesn't have a 3 on it, so it's real. 4, 5 that way. These are 4, 5. I still don't, oh no, now this is 3, so this is not 8, that's 6. That's a 6, 7 pair. And the other pair is 1, 8, and I don't know the orientation still. Yeah, 1, 8. Huh. Okay. That's fine. Totally fine. There's no 3 here. So if this is 9 or 3. If this is 3, it's a liar line. And it can do most anything. I don't think I know anything about that or that. Do I know something about this? It almost can't be a 3, but I could put a 3 here. It certainly isn't a palindrome line. So either, there's 2 possibilities. Either it's telling the truth, and it's a zipper line. And it couldn't be a 4, because that would be 1, 3. It could be 5, because that would be 1, 4, because 3 would be a liar. It can't be 6 or 7. So it'd have to be 8 without 2, 6. It has to be 8. It doesn't work. Wow. None of those work. None of those work. Is that right? Hold on. Let me try that again. If this is a real zipper line, what is this cell? Well, what is this cell regardless? It's 1, 4, 5, 8, 8. Done. If this is real, there's no 3 on it. This is the sum, so it can't be a 1. I'll just go through it because I'm pretty sure this is gonna work. If it's 4, first I'm gonna put a 3 on it because that'll be a 1, 3, which is bad. But there's also a 1 here. So either way, that doesn't work. 5 can't be 2, 3 because I would put a 3 on it, which is the liar cell. And if we're assuming this is a true zipper line for a second, can't be 1, 4. So now we're left with 8. 8 can't have 3, 5 because that would have a 3 on it, making it a liar. It can't be 2, 6 because of the 6, that'd be 1, 7, but there's a 1 here. Yeah. So this is the same difference line. It has to be lying, and so there's to be a 3 on it, which goes here. I guess I knew 3 was one of those 2 places, which if I had realized earlier, I might have been more credulous that that was correct. And so this is the same difference line. It can't be 3, 2, 1. It could be 3, so it's not going down, so it's going up. So it's either 4, 5, 5, 7. It can't be 6, 9. It can't be more than that. So those are my choices. Either way, there's a 5 here. Look at that. 5, 4. And this is now 1, 8. Amazing. Amazing stuff. Can I do the same thing up here? If this is a real same difference line, let's try it the other way. If this is a liar, then there has to be a 3 on it, which doesn't go in the middle. So there's a 3 here. What would 3 pair with? Not 1 to get 4. 2 to get 5 works. So we can't put another 3. 4 to get 7 doesn't work because of this 7. 5 to get 8 doesn't work because of this 5. 6 to get 9 works. So these are my... Oh, no. This 5 doesn't work. I didn't see that. So 3, 6 to get 9 works. Or it's the same difference line where there's no 3 and no 1. That seems really wide open. What would this be if it's the same difference line? Okay, let's just... do I want to do every possibility? Well, this is actually this is at least 6. Hold on. This is harder to be the same difference line than I thought. This is a 9 if it's a zipper line, because 9, 6, 3 was our only possibility. If it's 8, we get 9, 7 here, which doesn't work because I have 7s, and both 7 has to go up here. So 8 doesn't work. If it's a 6, we have some choices though. If it's 6, we can't do 5, 7 because there's no 7. So the choice would be 4, 8, which does work. Okay, so it's either, this way, 4, 8, so this 4, or 3, 6 in some order. Oh, I know the order actually because of this 6, or 3, 6. So this is 6 either way? Is that right? I think it is. It's either 3, 6, 9 or 6, 4, 8. Yeah, there's a 6 here no matter what, which means I get a 6 here by Sudoku, which maybe will help us with this line. What's going on with this line? This can't be a 3 anymore. So if this is 9, that's 9, which is totally fine. Put a 9 here. Yeah, okay. If this is a 3, it's broken. It could be a zipper line. What would I put with a zipper line here? Not 1. 2, 5 doesn't work, so that's 5. 3 doesn't work, so it's going to be a palindrome line. Also, there's a 3 here. 4, 7 doesn't work. 5, 8 works. 5, 8 works. But 6, 9 doesn't. So that's actually pretty. If this is 3, oh, but that was just the zipper. What if it's the same difference? 3, 2, 1 doesn't work, so we got to go up. 4, 5 works. 5, 7 doesn't. 6, 9 doesn't. So there's actually, that's if that's a 3. And if it's a 9, this could be literally anything that's not marked. So I don't want to mark that. Let's try this one. Oh, this is a real one. Ah, that's a 7. There we go. Because I couldn't put 3 anywhere on this palindrome line. So it's a real palindrome line. This had to be 6 or 7, but couldn't be 6. So they're both 7. And this is just now whatever. I have to have a 7. Oh, 7's here. So that's 7. That's 5. 7's here by Sudoku to make the same difference line work. That has to be a 5. That might have done something here. Hold on. Let me just try to do more Sudoku. 1, 8, 9. goes like that. These 4 digits are 2, 4, 6, 9. So 6 and 9 have to go in here. Not so helpful. 1, 2, 4, 8. Is that what I'm missing? 1, 2, 4, 8, 2. Are these 1, 4, 8? I think so. Okay, now let's go back to this line. I already forgotten what the thing was. So 3, if this is a 3, it's lying. And we'd have to have, so if this is a zipper, 4, 1 doesn't work. 8, the 3, 8, 5 looks very promising. Oh, and this can't be 9 anymore. This can't be 9. This can't be 3 or 9. So if this is a 9, I have to put a 9 here because it would be a real palindrome line, because this is the only place I could possibly put 3, which is our liar digit. So there's no 3 here. If this is a 9, it's a true palindrome, put the 9 here, so it's not. So that is a 3. What are those 2 digits? Those are 2 or 5. So 3, 1 doesn't work as a same difference or a zipper. Zipper is clear. 1 is less than 3, let alone whatever I add it to. 3, 1, we have to put another 3 here, which doesn't work. So that's not 1. 3, 4, 5 works as the same difference. 3, 8, 5 works as a zipper, but this is 5 either way, I think. So this is 2. We'll put it here. 5 is a zipper, nothing with the same difference. So that's 5 either way. What has to go here? 3 and 9, which don't go there. This is a 3, 9 pair. And this is 1, 4, or 8. 1 or 4. This can't be 8. So that's 8. And then, sorry, I have a little cut here. My kids are home today, and there's a little screaming I have to deal with. So anyway, I'm trying to remember where I was in this puzzle. Oh, I have no idea. Okay, let's do these. These are 2, 5, 7, and this one's 5. This one's 2. Okay, and 3, 4, 6, 8, 9. 8 is down here. This is a 3, 8, 9. So this is 3, 8. That's 9. No, this is 4, 6, 4, 6. So that's 9, and that tells me this is the fake one, right? Hold on. Let me just remember what I was doing here. I think it's, if this is lying, it's a zipper 3, 6, 9. It's telling the truth. It is an 8, 6, 4. I think, wow, hold on. I know this is a 9. Well, and one of these had to be a 6, so that's a 6. And then, okay, what is this? 6, 9, 8 is not a valid same difference line, so that's gotta be wrong. That's a zipper. Okay, that works. 8, 6, 8. I should know that's 2. 6, 2. That's 7 at the bottom, gives me 1 and 7, which gives me 1 and 8, which gives me 3 and 8. Well, I really had like nothing left to do at that point. Okay, this is 1. I could have gotten those from the zipper as well. 1, 2, 4. Let's just do these pairs of digits. These are 2 and 5. These are 4 and 9. These are 6 and 8, which gives me these. Oh, I need these. There we go. Cool. Very nice puzzle, Marnie and Patrick. I really enjoyed that, and I think I got very lucky at the beginning, going that smoothly. Anyway, so I hope you gave this a try and enjoyed it as much as I did. And thank you for watching.